Good. So I took over this part because this is a relatively recent development with a lot of breakthroughs, and Tilman was apparently a little bit uncomfortable talking about it without knowing too much about details. So it's only a few slides, but it's going to be my turn. But at the same time, I think for this reason, it might be also interesting for those who were involved in PMD some time ago, because it's certainly something completely new. Okay, so before I start talking about the semantic integration, maybe I'm going to talk about the problem of not having semantic integration. Well, if you have a workflow like, okay, here in this example, I'd like to give one step, like to get speed from distance and time, and everyone knows that by dividing distance by time, you can get the speed, right? So for humans, it is an obvious step, but for computers, it makes no sense, or it means nothing other than the fact that there are two floats in the input, and there is one float for the output. And it is up to the human to understand or to interpret the result correctly in order to make sense of the results, inputs and outputs, and how to use it, right? Okay, and this is the reason why you need ontology in order to give the meanings to the data and also the workflow step. And I think it is obvious to a lot of people, or actually all of you, that this is an important part of the workflow activities. But at the same time, this is not something that is done always. Actually, it is almost rarely done. There are probably multiple reasons to this. And one of them is obviously the fact that there is just no ontology available in your field. That is a tricky one, because first we humans have to develop one, right? But even there, if there is an ontology, very often we don't use it. And in this slide, I basically summarize why we don't do it. So as a scientist, you'd like to use a tool like, or you'd like to use a node from library, yeah, like for in this example, get speed, right? And you'd like to make sure that this has an ontological information. But the node developer who created this node probably didn't really care about the ontology, so they probably wrote just this node, right, without any semantic information. And the ontologists, on the other hand, they are probably only concerned about that the ontology is complete, and then they definitely don't come to the library to make sure that these tools have semantic information. So as a scientist, probably you end up creating the data first, and then you have to manually translate the data into some format that can be understood by the computer. And very often this is something like a JSON format, or it could be also RDF format. It doesn't really matter. But very often you are left with the data and ontology separate, and you don't know what to do. So the basically is that the responsibility is unclear, right? And then it is also like it's not so much work, but you don't want to do it every time. Maybe you can do it for some important information, but you might not think about it, yeah, and you didn't like to do it for each and every calculation. And this is the problem that we are facing on the technical level. And then the solution we came up with, it was to include this information directly into the node. So on the left-hand side, you can see again this same node, yeah, that gets speed. And what we mean, obviously, is that the distance and time as inputs, and the output is the speed. But what computer sees, again, is just these are three numbers, right? So how about just making the computer see what we see? And the great thing about the Python, or the recent Python, I think since 3.7 or 8 or so, is that there is now a possibility of not only giving the type annotation, yeah, not only integer, float, and so on. You can actually also put metadata to the arguments, such as in this case, you can also put something like universal resource identifier. And as the name universal indicates, this is an identifier that is used all over the world, right? So here in this case, I just put some example identifier identifier, right? But in principle, you should put something that can be also globally understood. And on top of this, maybe you can also put, for example, units. Yeah, if the distance is given in meter, then you'd like to indicate that this is meter and not nanometer, and so on, right? And you could maybe also add more things like what is the relationship between the output and the input, and what kind of constraint, and so on, right? And in the end, with Semanticon, you can read this workflow once the nodes are annotated with the semantic information, and you can extract the whole recipe, the workflow recipe, so basically the whole workflow, in order to create a knowledge graph that can be universally understood. And you can also do the same thing for the data if the data, if there's an enough notation for the data as well, right? So this is a little bit of a paradigm. I mean, maybe it's too much of an expression if I say paradigm shift, but we would like to create nodes in the way that if you use it, there is already ontological information attached to the workflow that you're executing, right? And then we came to the next step. Well, actually, if we can do that, then why not work with the co-ontology people, right? So the PMD co-ontology has been introduced already a few times, but they have been working on mostly the material scientific data. But then we worked very intensively in a couple of weeks or months up to today in order to create a full ontology that is based on basic formal ontology. And if you're not familiar with basic formal ontology, this is something that was developed by proper philosophers in order to create a universal basis for all the ontologies, so that we can also talk with other fields, like maybe also with biology, medicine, and so on. So it is a little bit like an ideal situation, but in principle, if you use PMD core ontology, you'd be able to talk to people working in totally different fields as well, right? And this PMD-CO is directly translated into Semanticon, and using the Python workflow, which can export the data or the workflow in the Python workflow definition or Python workflow description format that Tilman just introduced. And then you can translate this into a knowledge graph without actually doing anything other than putting an annotation in your nodes, which should probably be done already before you use the node. And then once you have the knowledge graph, yeah, you probably start wondering, what can I actually do? Yes, I talked now a lot about knowledge graph without actually talking about the benefits. And here it's not so much about the Semanticon feature, but this is going to be certainly a feature that you'd be interested in using. So the first one is that now between Python and the database solution that you already have, because probably many of you already have some SQL database or OpenBS database, or maybe even the triple store solution. I'm not sure what kind of solution you already have, but you probably have a solution. And you might not want to directly connect it to Python, because Python is a solution, like it's not a temporal solution, but it is always under development. Yeah, we try to add more features and so on. So the connection between Python and your database solution might not be permanent. On the other hand, knowledge graph was created by created on the philosophical basis. That means it is in principle something that will stay permanently, because we developed it on the philosophical conceptual level, right? So that means it is not something like technicality might change, but the foundation will not change. Yeah, so you can probably trust it more easily, and so in this regard, you don't have to create a direct interface to Python. And then not only Python, but it is actually even Python independent, because RDF can be stored in any format. Yeah, it could be also text format, and you can also read in a totally different platform. And that means you can also connect it to experiments, like via ELAP FTW. That is also commonly used by experimentalists, and they very often already have an infrastructure in order to translate their data and workflow into a knowledge graph. So you can straightforwardly combine the knowledge graphs in order to have a combined database. And so this is the conversion part. But another benefit is that you can also do ontological reasoning, such as if the class is compatible. Yeah, okay, this is something that you could also do with Python, but you could also do unit conversion, right? Or you can at least check the unit compatibility. But then if you have a step which is in angstrom and then you want to do the next step in nanometer or so, QUDT is again another ontology. It also allows you to, or it gives you the conversion factor in order for you to make sure that the conversion takes place properly. Or you can also create something like properties, because the ontology is often actually not often, it's based on triples, right? In our case, that means you can also say something like, my material has a vacancy, dislocation, grain boundary. And if you have a grain boundary of this type and so on, that would be very, very difficult to define with Python classes. And then also you can create constraints, because you might want some very special input, like I'd like to have a material which has this property, like it went through this treatment and it has no vacancy and so on. Yeah, and then on the technical terms, you can also create, you can use also shackle, og, and so on. And if you are lucky, or if the ontology is properly created, you might be also able to find more data than what you were expecting across the reasoner that you use. Okay, so I talked a lot about what kind of great things you can do with semantic on the knowledge graph, but I'd like to make sure that you are properly informed. So as I already said, we provide an infrastructure for you to be able to make sense of your workflow using the application ontology based on your application ontology. Yeah, and that again has to be based on basic formal ontology or PMD core ontology, right? And then there is also some basic Spark query writer, because those who are familiar with the queries in the knowledge graph, it is actually pretty hard. Yeah, so this is more like a technical detail that you don't have to know. But if you are wondering, there is a way to look into the knowledge graph a little bit. But what we do not provide is the ontology and the reasoner, right? So that means if you have some field, some specific field, like your field, for which there is no ontology, you can actually also talk to us, but the right person or the right team to talk to would be the ontology group. And as Tilman already indicated, there will be another session that will take place today in 1 week. And then I put Jörg Weitlonis, because he's the person that helped me a lot to develop Semantic, and he basically created the PMD core ontology for the workflow description.